we always make a joke that it's something that their mommy also had when she was pregnant, and if we are going to see any babies in their legs, and then they laugh a little bit and
Hi everyone, today we are not speaking about babies in legs, but we are speaking about muscle ultrasonography in children with cerebral palsy. Today, Britta Hanssen, a Ph.D. student of KU Leuven, will present us her recent study. So enjoy the video.
Hello, Britta. Thank you very much for coming today and joining us in Science in the Break. Today, we will talk about your recent paper, right?
Yes, well, thank you very much for having you. I'm excited to be here.
Nice, thanks. So tell us, Britta, what is your study about?
So we worked on muscle weakness in children with cerebral palsy. And we want to see if the underlying muscle volume deficits that we see, so the deficits in muscle size, are related to their muscle weakness and to what extent they contribute to muscle weakness in this patient group.
And why is muscle weakness important for these children? Do they all have it, or?
Yes, it's a very common symptom in children with cerebral palsy. And is also one of the main problems that is associated with their daily functioning, for example, in gross motor function, in walking, etc. Yeah.
So that is also normally a target in treatment?
Yes, yeah, it's often.
I see. And what were the main findings of your study?
So we looked at 4 muscle groups and we defined both isometric muscle strength there and muscle size of those muscles. And we found that there were deficits in muscle strength, like we expected, and that there were also deficits in their muscle size. But the deficit in muscle size is not to the same extent as the deficit in muscle weakness. So there are other factors contributing to the muscle weakness, like, for example, the neural ability of the children or a selective motor control. And we actually looked at how much does this muscle volume deficit contribute to muscle weakness. And we found that it actually differed between the 4 muscle groups that we looked at, but also between the children or the patients that we included.
So this was actually a result in itself, this high variability, and that we should maybe look a bit more into individual factors in these children and why these individual factors have an impact on muscle weakness. That would be very important and interesting for the children themselves too, and for the physiotherapists also to plan their treatment, because that's otherwise if we do always the same. Britta, when you mention muscle volume, muscle size, and so on, how do you do that?
We used a 3D freehand ultrasound technique. So it's a combination of a 2D B-mode ultrasound with a motion capturing system. So we sweep over the muscle of the child, and with the combination of those 2 techniques, we have the position of every image that we take, and we can create it into a 3D reconstruction of the anatomical area that we scanned. And in the 3D reconstruction, we can define landmarks. So we see how long the muscle is, but we can also segment the cross-sectional areas and create a 3D reconstruction of the muscle volume.
Oh, okay, very cool. And how long does it take, such a measurement?
Well, the actual assessment of one muscle is about 30 seconds to 1 minute. So, and the child has to lay still, but it goes pretty fast. Preparing and cleaning afterwards with all the gel might take a little bit longer. So I think 20 minutes for the 4 muscles that we did is definitely feasible. The processing afterwards is a bit more time consuming. It's about 30 minutes to 60 minutes for 1 muscle to define and volume. Yeah.
So the data collection is quite easy compared to MRI or other imaging techniques, yes, if to maybe see the same outcome, no? Similar outcome. Oh, nice, interesting. What motivated you to do this research?
Well, like I mentioned, we know that muscle weakness is a very important symptom in these children, and we also knew that they have deficits in muscle size, but the relationship between those 2 was examined, but once in this muscle and once in that muscle and in very small groups. And we really want to figure out like, how is it the same for all 4 muscle groups? Are there differences between children in a larger group? So that's what motivated us partially. And then it's part of a bigger study where we actually did a training intervention. So it's a nice start off to see what is going to happen once they have been trained.
And what would you say that is the coolest results of your study?
What I think I like most is when we did, we kind of predicted what their actual strength would be or was supposed to be, because we were doing regressions and correlations with muscle volume and muscle strength, and at some point we were like, we were always working towards the strength that we measured, but not towards, we don't know what the gap is. Like, we don't really know what the deficit, we know like, okay, it might be 30% or 40% in general, but we didn't really know how much the individual gap for each child was. So we used our TD data to create regression equations to define, like, based on their height, like what would be their norm strength. If a child of this height, of this age, how strong would it be? But then also based on their muscle volume, which is of course smaller than it would be for the child of the same age, how much potential strength would they have if they could use their whole muscle volume for the strength production. And based on that, we created these profiles to see how much the volume reduction contributed to the weakness and how much other factors, for example, the neural factors, contributed. It took a lot of time to figure out where we wanted to go, but I think that's the coolest part of the paper.
Yeah, nice. It's nice to hear. It's also nice. It's also cool to see how you struggle with the research question, but eventually you found a way to get to a nice result that you can also give its importance in the clinics. What was the part that you found more challenging for this paper or for this study?
I think that would be the data processing. Like we mentioned it shortly already. It takes a lot of time. It's very time consuming. I started with the TD children, and that went okay because those muscles are clearer and the images are often of a higher quality. And then I probably started subconsciously with the more functional CP children, and then in the end, all the hard files were left. That's what I struggled most with, to actually finish the data before continuing to the next step.
So all the data processing is manually, or is there any automatic processing that you can do on the data? Unfortunately,
there's no automatic processing yet. I think it would be really happy would happen at some point. So if someone's interested,
please do it.
Yes, we would be very pleased.
Well, thank you very much, Britta. Those are all the questions. I hope that the audience finds it interesting and that they can read the paper, which can be found in the link. We hope to see you soon again in Science in the Break, Britta.
Thank you very much for having me. Yeah, we said making a joke, how to approach the children, also give them a feeling of accomplishment at the end of the assessment, like, oh, we saw how strong you are and you did really well, and you have very strong legs, and oh, look at those big muscles we can see in the computer. So doing the measurements and actually giving the children also a feeling of, yep, letting them go with a positive feeling, like I accomplished something.
It's nice to see that that you really like working with children and that you actually do a good job, I think. Do you agree that we record? Okay, perfect.